Okay, multiplying and dividing rational expressions. So at its simplest then, we could just go back to when you multiplied and divided a fraction, right? So let's say something like 5/9 times 3/25. So when we multiply fractions or rational expressions, really it's just multiplying the tops together and multiplying the bottoms together. Okay? So we could write this as 5 times 3 over 9 times 25. And what we could do next, which I'll show you, which isn't something that we would do usually, but what we could do is write this in a factored form. So the top would stay as 5 times 3, the bottom would become 9, which is 3 times 3, and 25, which is 5 times 5. Okay, and now we can cancel, so the 3 takes out the 3. And when you cancel, when you're dividing, you're really dividing top and bottom by 3. You're leaving behind a 1, and the 5, and that 5. So we're left with 1 up top, and 15 on the bottom. Okay? Now, that's something we would never do with fractions. Okay? With fractions, you would go 5/9 times 3/25, and you would say, okay, that goes into that 5 times, 1 goes into that 3 times, and we get 1 over 15, right? We would just pretty much cancel in place, right? But, you know, we're not working with fractions here, right? I mean, well, we are. But what we want to work with is rational expressions. So let's do some rational expressions. So let's just go to a new page here. Sorry, question? Okay, so let's take a rational expression. Let's try this one. 3a squared over 2b squared times 10b squared. Sorry, b cubed. Let's make that a cube. 10b cubed over 9a squared. And we're also going to state restrictions on variables here. Okay, so what are the restrictions on the variables? A cannot equal 0. B cannot equal 0. Okay, so neither A nor B could be 0. It would just lead to bad things happening, right? So we don't want that to happen. Is that A squared? Oh, sorry. This should be an A cubed. Let's change that. Make that an A cubed. So what you can do is you can multiply it out. And again, something that I probably wouldn't do, but so we can get 30 A cubed B cubed over 18 A squared B squared. Okay? Now you can factor that. So if we look for the greatest common factor of 30 and 18, what is it? 6, right? Biggest number that goes in is 6. So we could say this is 5 times 6, okay? And then if we want to continue on the idea of factoring, we would say, well, the largest factor of A that's in common is A squared. So I write that as A squared times A. And the largest factor of B that's in common is B squared, and then B. And I want to factor the bottom the same way, right? So the common factor of the number is 6. So I don't want to write it as 2 times 9, right? I want it as 3 times 6 so that the 6's cancel. Okay, we're looking for greatest common factors. The A squared is already the greatest common factor, as is the B squared. Okay, so now I can cancel common factors top and bottom. Okay, and then this B squared and that B squared. Leaving me with 5 times 1 times 1 times A times B, so 5AB over 3. Okay? And the non-permissible values still hold, right? A cannot equal 0, B cannot equal 0. Don't forget them because we wrote them up top. Right? So what we're saying is, basically for any value of A and B, if I evaluate this expression here, I will get the same answer if I evaluate this expression here, right? That these are equivalent expressions as long as A is not 0 and B is not 0, right? Which is perfectly fine for this. Down here, you can put A or B as 0. It's fine. It works out. But you can't do that in the original, right? So our restrictions are always on the original. All right, so you could factor that. More likely what we would do is probably just, again, do this in place. 3 goes into 3 once and into 9 3 times. 10 divided by 2 is 5. The b squared is gone, leaving me with a b. The a squared is gone, leaving me with an a. So I've got a 5ab, and on the bottom I've got the 3. Doing it that way, though, you can lose stuff pretty easily, right? Okay, but you'll still get the same answer, 5ab over 3. All right, let's go on to the real stuff, the stuff that we're mostly going to be looking at. So multiplying rational expressions involving polynomials. So let's pull one here. X squared plus x minus 6. So more likely they're going to look like this. Over x squared plus 2x minus 15 times x minus 3 over x minus 2. Okay, we're kind of going to do the same 3 steps that we've done before, right? The first step is to factor, okay? So I want to factor. So first I'm going to start off by putting an equal sign down, right? Because what I'm about to write is equal to, it's equivalent to the line that's above. And we're going to factor. So how does x squared plus x minus 6, how does that factor out? You know, and I guess basically we kind of know that, and I'm just going to bracket these off, but all right, you want to factor x squared plus x minus 6? Okay, x minus 2, x plus 3. Want to factor x squared plus 2x minus 15? X minus 3x plus 5. Okay, so that's step 1, factor. Numerator, factor, denominator. What's step 2? What's step 2? Non-permissible values, right? So what can't x be? Negative 5, positive 2, positive 3. Okay? So step 1, factor. Numerator, denominator. Always check your factoring, right? I mean, you know, get x squared plus 3 minus 2 is plus 1, plus 5 minus 3 is plus 2. You know, usually you're going to make a mistake on the middle term, right? It's not usually you get your last term wrong or that. Usually the middle term ends up with the opposite sign than it should have. Okay, and now we can cancel anything on the top with anything on the bottom. So I could write these together, right? Like just remove the times, put that down. So here, I'll do it, and I'll say I could do this. So I could write it as x minus 2 times x plus 3, whoops, and then just write this one together, x minus 3 over x minus 3, x plus 5, x minus 2. So we can do it. You don't need to do that, though, right? You can just cancel. Basically, once you've written it as a times, you can cancel anything on the top with anything on the bottom. Any top. So, you know, I could cancel. I'll do it down here. So the x minus 3, cancel. The x minus 2's, cancel. Leaving me with the final answer of x plus 3 over x plus 5. Okay, questions? Sorry. Okay. Now, usually I would just have done that up here. Okay, so I would have just said, all right, I got an x minus 3 on the top, x minus 3 on the bottom. Cancel. X minus 2's, cancel. Left with x plus 3 over x plus 5. There it is. Okay? So you don't need to show this step. In other words, you don't need to write them all as just one thing, right? As soon as it's turned into a multiply, any top cancels with any bottom. do another one. Let's do a division. X squared minus x minus 20 over x squared minus 6x divided by x squared plus 9x plus 20 over x squared minus 12x plus 36. Okay, so give me a moment to write that down. So this is a division, right? We're dividing by. So what do we do when we divide by fractions? Multiply by the reciprocal, right? So the first thing we're going to do is we are going to now change this into a multiplication. So the first expression stays the same. Then this becomes a times, and you take the reciprocal. So it's x squared minus 12x plus 36 over x squared plus 9x plus 20. Okay, so when you're doing division, you've got one step beforehand, which is turn it into a multiply. Then you do your factoring. Okay, so we're going to turn it into a multiplication first, then we're going to factor it. All right, so multiply, let's write this in here. Multiply by reciprocal. Okay, then factor. So it simply adds a little step. Okay, equals, so x minus 5, x plus 4, x bracket x minus 6. Okay, those are pretty easy. Now I'm going to expect to see these factors appear again. You know, I'm willing to bet there's an x minus 6 on the top of this expression, okay, which there is, because this is x minus 6 squared. And I'm willing to bet there's either an x minus 5 or an x plus 4 over here. Now, seeing as these are both positive, if one of these guys is a factor, it has to be the positive one, right? I can't have a negative. So then it's probably x plus 4. And it is, because the other one is x plus 5, right? X squared plus 5 plus 4 is plus 9x plus 20. Okay. So step 1, if it's a divide, step 1, rewrite it as a multiply. Multiply by the reciprocal. Step 2, factor. At this point, make sure that your factorization is correct. Okay, so FOIL them all out, just check it over. Step 3, non-permissible values. What can't x be? Negative 4, negative 5, what else? Positive 6 and 0. And there's actually one other, although in this case it won't matter, but 0, what do we say, negative 4, negative 5, positive 6. When we're doing a divide, we actually have to check in 3 places. Because what I'm going to do, I'm going to circle in red the denominators, right? So these are the things that have to be checked. You have to check this, because it's a denominator, right? X squared minus 6x is a denominator. And it is here, and it is here, right? So as it comes down in its factored form is where we do the non-permissible values. X squared minus 12x plus 36 is a denominator. Then it moves, right? And it becomes a numerator. But originally it's a denominator, so we have to check it for non-permissible values. Right? In this case, it's already covered off by this one. Right? But you have to check that. And x squared plus 9x plus 20 becomes a denominator here. So now it's a denominator. So we have to check, when you're doing a division, you have to check 3 different denominators for your non-permissible values. The original denominator, when it was written as a division, because we can't have 0 here. We can't divide by when we're dividing by 0. You're not allowed to divide by that. Okay? Then that flips up here. So basically, you're checking everything but the numerator of the original rational expression. That's the only thing you're not checking. Okay? So anything that is a denominator or at some point was a denominator must be checked for non-permissible values. Okay, and now we can simplify. So what I'm going to do is I'm not going to write them together. I'm just going to start canceling top and bottom. So the x minus 6 here takes out the squared, basically, right? Leaving me with just one x minus 6 up here. The x doesn't cancel. X plus 4, x plus 4, x plus 5. Don't cross that off because it doesn't. X plus 5. Okay, that does not cancel with the x minus 5, right? And it's not like I can factor a negative 1 out of this, because it'll just become negative x plus 5. So they're not the same, right? They don't have opposite signs. They're both positive x's. One is a plus 5, one is a minus 5. I can't turn one into the other by, factoring something out. All right, so all we're left with is on the top, we have an x minus 5, and then a 1, and then, and an x minus 6. So let's keep that. And on the bottom, we have an x and an x plus 5. Okay, and that will be the simplified form. With our non-permissible value, right, x cannot be 0, negative 4, negative 5, and positive 6. Okay, question? Oh, good. Okay, let's try another one, just like the other one. You guys get off light. All right, here's a nice one here. I'm pulling this out of a Math Power 10 book, right? It's an old grade 10 book. That has to be a 30 ST. Otherwise, it wouldn't factor. Oh, let's make this a division, just so we get some practice doing division. Okay, there we go. So what's our first step? Nope. Make it a multiplication, yeah. So first step is turn it into a multiply. Equals. So all we're going to do is just rewrite this first expression. Times, and then we're just going to flip this, or take the reciprocal. Okay, so you can see stuff like this on the quiz Friday, right? So I mean, today we'll do the lesson today. You've got a few questions assigned for today, and then tomorrow will just be a straight work period. So basically you've got, we finish this and then you've just got today, the rest of today and tomorrow to work on the multiply and divide stuff. Get everything ready so you're worked out and ready for Friday for the quiz. Okay, now we got to factor. So what's easier to factor than 9s squared plus 30st plus 25t squared, or the 25s squared minus 25st minus 6t squared?
I don't think it matters.
Yeah, it does. Top one, because top one is actually a trinomial square, right? Because 9s squared has a square root, which is 3s. And 25t squared has a square root, which is 5t. 3s times 5t is 15st, doubled is 30st. So that tells me that this factors as 3s plus 5t all squared. Right? So that's recognizing trinomial squares. Makes it easier for you to factor that. Now I got to say, so do I think 3s plus 5t is a factor down here? And no, I mean it can't be. Okay, so times, let's go over here. I mean basically we know, okay, I don't think that's a difference of square. There's no squares there. So I'm just putting down the skeleton, right? This is what it's going to look like. I am willing to bet that 3s plus 5t is a factor of this. If it is, right, this is the if part, right? If it is, what goes up front here? 4s, right? To give me the 12s squared. So 4s. And what goes on the bottom, what goes at the back there? Minus 5t. Okay, now I didn't factor that, right? Or, you know, sort of fake factor. Let's check it out. So we get 12s squared minus 15 plus 20, which is plus 5 minus, yeah, so it is right. Okay? So now what I'm willing to bet is that 4s minus 5t will be a factor here so that it'll cancel, right? If it is, what goes up front? 5s. What goes at the back here? Okay, be minus 6t, right? In order to give us so to get the 20s squared, we got a 4s, we need a 5s. To get minus 30t squared, we'll need a minus 6t, or sorry, to get plus 30t squared. Okay, now we got to check that. So we get 20s squared minus 25 minus 24, which is minus 49. Okay, so that's good. Okay, then I'm willing to bet that 5s minus 6t is probably a factor down here. And if it is, to get the 25, I'm going to need another 5s. And to get minus 6t squared, I'm going to need plus 1t. Now, there's no way, we didn't factor that, right? We simply said, if this is a factor, then this is the other factor. Gives me 25s squared minus 30 plus 5, which is minus 25 minus 6t squared. Okay. So if you think about it, in doing this question, I really only factored one of the four expressions, right, which was the top left. That's the only one that I actually said, okay, let's factor this. So you have to start off by factoring one of them. After that, it just sort of became, well, that 3s plus 5t, I'll bet you, well, it can't be a factor down here, so it's not going to cancel down here. So I'll bet you there's one of them down here. And if there is, this is the other factor. Then we checked and said it was. Okay, and now I've got this factor here. Well, it's not going to cancel with anything over there, so I'll bet you it cancels up top here. And if it is, then this is the other factor. And then we checked, and it was. And then if this is going to cancel, then I'll bet it's down there. And if it is, this is the other factor, and then we checked them all. So we factored one out of four expressions, and we sort of, we factored them, but, it's sort of like, fudgy, fake factoring in rational expressions, because we're saying, well, I think there's going to be a bunch of cancellation going on. So, and again, it doesn't matter. You could just straight factor all four expressions independently, right? It takes longer. Yeah, it takes longer, right? Certainly. Yeah, this gives you a clue, right? Because it says, well, probably this is a factor down here, okay? And if it's not, then you'll actually have to factor, right? You'll have to go in. Okay, but it is. Okay, so the next thing we do is now we state non-permissible values, which is going to require a little bit of space, and we got to keep in mind, what do we need non-permissible values for, right? We need it for this one, and this one, right? Because this and this are currently denominators, but this was a denominator up in the original question. So when you're doing the division. Okay, so let's list non-permissible values. Okay, 5s plus t. So what are we going to say? Let's do it in terms of s. So what can't s be? Negative t over 5, right? Move this over to the other side, changing its sign, and divide by this. Can't be 6t over 5, right? Again, move this to the other side, becomes positive 6t, divide by 5. Can't be, so negative 5t over 3. Can't be was 5t over 4. Can't be. Well, these are the same, and those are actually the same. So we're good. We've covered it all off. Okay. So those are all the non-permissible values. You could do them in terms of t as well. Right? I mean, you could say t is not equal to, but let's just stick with whatever the first letter in the alphabet is and do it for that. So, if it's x's and y's, do it for the x's. If it's m's and n's, do it for the m's. If it's s and t, do it for the s. You don't have to do it for the other variable. No, you just have to do it for one. Your device is flashing.
What?
No. Somebody has a flashy device. No. Your device is not flashing. Okay, so now we can go through and we can do the, I could write these together. I don't bother with that, right? I say any top with any bottom. 5s minus 6t, 5s minus 6t. There's 2 of these, so we're going to take one of them out, right? That's a 1. 4s minus 5t's are directly. And that's it, right? All of that's gone. And all we're left with is 3s plus 5t over 5s plus t. I was going to watch. When you're writing t's and plus signs, make put a little curl in the bottom of the t so that that's a t. And nope. Said that earlier. You only need to do it for one variable, and we're going to go with the earlier one in the alphabet. If, however, you choose to do it in terms of t, I will look at it and mark it accordingly. But I would just say, to make life easy on everybody, let's just stick with the lowest, the letter that occurs earlier in the alphabet is the one we'll do it. Yep. Those large things. I think that's pretty much it for multiplying and dividing, right? I don't have much else. You're getting away with, because here's the page out of the 10 book, right? Which is like, here's 100 of them to do, right? You have probably about 8 or 10 in total in your book, or maybe 12 in total. And then it gets into the word problems. So what's assigned for today? And also, there's certain questions we aren't assigning, so you don't need to do that one. But just take a look at your outline, and today, rest of today, all of tomorrow, we have to work on multiplying and dividing.
Are we doing 2 lessons today, or no?
No, there actually isn't 2 lessons. So the stuff that's for tomorrow, the questions are for tomorrow, more application questions, but they're it's not something we really have to do examples of. You just read the problem and you'll figure it out. Right? They're not. They basically lead you to the equations.